A square of side 100 centimeters is placed in the plane of the paper. So the laptop screen can be the plane of the paper. A square of side 1 meter 100 centimeters placed in the paper. The field is uniform. The value of the field is 0.04 volt per meter, acting parallel to the same plane. That means it is in the plane of the paper, in the laptop screen. With one side of the square making an angle 60 degree as shown in the diagram. The one side of the square and electric will make 60 degree theta. Find the electric flux through the square. So the electric flux formula for a single surface is EA cos theta. In that, E stands for the magnitude of electric field intensity, which is given 0.04 volt per meter. Is the magnitude of area. So side is 1 meter, area is 1 meter square. Then theta. Theta is the angle between the directions of E vector and A vector. Important, angle between the directions of area vector and electric field vector, not with the side. Here the angle is given between side and the electric field vector. But here theta in electric flux calculation is always angle between the directions of area vector and E vector. For example, if you consider a circular area, the person looking from the top, the area vector is always normal and outwards, so upwards along j cap. That's the area vector. Now if the electric field line also upward, means normal to the surface. In that case, both are parallel. The theta will be 0. That means if the field lines are normal to the surface, it will be making electric field vector and area vector parallel to each other. That time theta will be 0. For same diagram, the area vector will be still upward, normal. But if you take electric field lines along the surface, parallel to the surface, so it can be any direction, right, left, up, down means forward, backward, left, right, not up, down. Up will not be parallel to the plane. So it can be in the plane anywhere. Or it can be towards right, it can be towards left, it can be in and out of the screen. But now the area vector and electric field lines are 90 degree. So this particular case, cos 90 will be 0. So any case, if the electric field lines are parallel to the plane of a sheet, it always make 90 degree the area vector, because area vector is normal to the plane of the paper. So in that particular case, the electric flux will be, you don't mind E and A, whatever value given, because cos 90 will be 0. So it's important to check theta is not the angle given here as side and electric field. Theta is the angle between electric field intensity and area vector. The theta will be 0 only when electric field lines are normal to the surface, because area vector is also normal to the surface. In that particular case, both E vector and A vector will be parallel to each other. Now, in any case, if electric field lines are given parallel to the surface, definitely that makes 90 degree with the area vector, because area vector is always normal to the surface. So that particular case, flux will be 0. In another case, to get the correct orientation of the angle, this is a surface given, same as before. So area vector don't change, area vector remains same as normal upward. Now if they given electric field like this angle, it's not parallel, not perpendicular, and sometimes they'll give angle made by the electric field with the surface. This angle they will give sometimes as 30, 40, 60 like that, with this 30 degree. The theta what we want for calculation of flux is between area vector direction and electric field direction. That is not this angle. This is the angle between these two. So this is theta. So that theta will be total area vector make 90 degree with the surface. So 90 minus 30, the theta what you want for calculation will be 90 minus 30 will be 60 degree. So that time flux will be calculated as the value of electric field intensity magnitude area vector magnitude into cos not 30, because 30 is with the surface and electric field. We want area vector and electric field which is normal to surface and electric field cos 60. Then the calculation can be done as per the question. So be careful about the angle given in flux calculations.